Thank you for giving me time. My name is Yamaguchi. In this session, I'd like to talk about technologies that support the data solution business, that is the analytics service environment behind the scene. Hopefully, this will help you build data analytics environment. Once again, my name is Hiroshi Yamaguchi. I joined Yahoo in 2012, and I've been consistently working as an engineer in advertising business, building an operation of Hadoop. Most recently, launched a new DS business. Currently, as a manager of product development team, I'm leading the direction of the DS API and DS dataset products. I also serve as a security manager in charge of the safety of data utilization. Let me first introduce our data solution business. Yahoo has multi-big data, and to utilize it, we have focused on advertising service and internal service improvement. And we want to expand that so that we can vitalize the economy of whole Japan. To this end, we developed the analytics service using search logs and location information logs to optimize upstream product planning and logistics. Now, we have introduced 4 different services to meet the wide range of user needs. We offer products like DS Insight, DS API, and DS Dataset. And analysts offer analytics services named DS Analysis. Now, let me introduce the product. DS Insight is designed to understand consumers. It's a web tool. It includes people to visualize users' interests based on the search logs, and place to analyze people's movement based on location information logs. And DS API has been introduced to link systems, primarily providing inside information at present. And DS Dataset realizes in-depth market and product analysis according to customer needs. Today, I'd like to focus on the system architecture of DS API and Dataset. The search log data that we deal with include search queries. There are about 8.1 billion unique queries per year. An example would be Yahoo Weather. You might use regularly, of which log data is about 100 terabytes per year. Currently, we use 500 terabytes of data that covers the past 5 years so that we can compare with pre-COVID data. Yahoo has about 84 million active users, meaning 4 out of 5 Japanese people use our services. So having so many users means an enormous number of searches made. So multi-dimensional analysis based on log data will enhance our understanding. For example, by comparing daily search rankings, we will recognize change in users' interest. By comparing search volume by keyword, we will see an emerging trend. So what does this mean? What does it mean to deal with enormous amount of data? You may have analyzed. The more data you deal with, the more time needed for analysis. Therefore, we start to lose efficiency. Especially, it is not easy to simply store and use this large scale of data in the database. So the goal is to analyze quickly and apply the findings backed by data to our business. In order to do this quickly, it becomes critical how efficiently we can handle data. So from here onward, I'd like to talk about several topics on the analytics environment, about what problems we are working on. So the topics, there are 3 topics that I'd like to cover today. First, I will talk about how not to keep the analysts waiting. Second will be how we can provide flexible analysis. And thirdly, how can we reduce pre-processing time. So then let's start with the first topic, not to keep analysts waiting. We don't want to spend time on aggregation. When you analyze data, what would you do if the data aggregation takes a long time? You would like to spend time not on the data aggregation, but the usage of collected and aggregated data. Explore the usage. Facing an enormous amount of data, you wouldn't want to spend hours in data aggregation. Here is an example of the function we offer, the analytic tool. The keyword ranking is based on a specific keyword. This example shows the ranking of the query about Yahoo. The ranking of keywords that includes Yahoo, this information indicates the user's interest. They are actually interested in government's offered coupons in Yahoo Travel or the bargains in Yahoo Shopping. And when you analyze or search, it's not just Yahoo. You may want to include other companies so that you know better about users' interests. Based on the analytic findings, we can take measures to satisfy customers' interest.
Now, what would happen if we try to acquire data from raw data? It is necessary to aggregate based on keywords and create the statistical information. And we need to do so for the multiple keywords such as gender, age group, and others. And if we do so, we cannot repeat the trials and errors. So as a function, we are showing this, but in the DS business, not just one, but for example, the trend of the search volume and the chronological change of the search are provided as well. In acquiring the data, we are trying to do this in a few seconds' time. As I mentioned earlier, to return the various functions at high speed, first, instead of using the large-scale raw data, we need to create a dedicated data mart. But as you can see in this diagram, if you simply based on the purpose and create the data, then the efficiency will be lost. So for that, how do you try to contain the storage cost is one of the challenges. This is the actual configuration image. So in order to have a short latency, we use the data mart configuration. So DSI people and the DSI API, in order to secure the latency and efficiently handle data, we create the dedicated data mart. Data mart on the Hadoop is the master data mart that is used as a business as a whole. So it's divided into the ratio of the age group and stored in the database as a statistical information. And the ranking information and other information are stored separately in the database. So by doing so, getting data directly from Hadoop, you cannot secure the few seconds latency, but instead you do this, you can quickly return. And the ranking information is sufficiently small in comparison to the statistical data. So you can reduce the cost of the storage even if the data volume increases. So what is the actual configuration? This is the example of the ranking. So ranking information, there is a dedicated data. As for the statistical data, this is a generic data, so it is kept as a wide table. So, for example, the ratio of the gender and the age group are aggregated, and actually we combine those at later stage. So by doing so, the ranking information of the keyword and the volume trend, those are the data used by many users. So this can be handled in a common way, and also short latency can be secured. And for that, we divide the data mart to optimize. At the same time, the aggregated data, these are aggregated data, so the deeper division is difficult to realize. Next, let me talk about the desire to provide more flexible analysis. So far, I talked about the generic analysis, finding out the general trend in the society. But for example, if you want to focus on the specific user group, what they are interested in, or for example, if you want to analyze a specific time period, such as Golden Week, it's not easy. So in terms of the search data, sometimes the different order of the words, but the same meaning, the Yahoo data solution and data solution Yahoo is one example. And with this, you cannot consolidate those for the analysis, and you will need the environment where you can handle those data more flexibly. So now I'd like to talk about how we take advantage of the data mart and try to extract the data more flexibly. So, for example, we conduct many aggregations by specific user attribute, specific time period, or by category. But if it becomes too flexible, the aggregation cost increases and execution becomes difficult. So for that, we have to consider the balance between the flexible aggregation environment for the users and computing cost. So this is the system diagram. In DS business, DS dataset and DS Insight Persona, those two services are provided. So this is, we handle data SQL-like from master data mart, and we have a job server for this. And the reason behind this configuration is something that I'd like to introduce now. So it's not really limited to Trino, but when you use the aggregation system like this, there are two challenges. One is the finite computing resource, and another is that this is the distributed system, so there is an issue of the noisy neighbor.
This is the validation data on the horizontal axis. The month, what is the aggregation period? And vertically, we have execution time. Up to 3 months worth of aggregation, the execution is possible, but execution time increases linearly. On the other hand, if the aggregation exceeds 6 months, the execution fails because it exceeds the Trino memory limits. Job itself fails. When the user number is increasing, user needs expand, the data that is dealt with, and computer resource control will be necessary. Now I want to talk about the aggregation period and the number of parallel executions. The graph shows the parallel execution of the aggregation period of 1 month. It linearly grows to 5 parallels. If it's 2 months aggregation, it's 3 parallel. When it reaches that limitation, execution fails. It's not just one job fails, all of the job would fail. That is a major problem. If a job fails, there will be an impact on users. How can we control that, prevent that? That is a difficult question about noisy neighbor issue. So multiple servers do use one single Trino. So we are thinking about how to minimize the possible impact. So in order to do that, we separated resources groups by service. By doing so, how much resource we can use is obvious. So within the service, it is easier to control. The other thing is Trino. It's not just requesting Trino. We will have management server in place. By doing so, how many parallels on raster server can be controlled easily, preventing the problem that I mentioned earlier. So for flexible analysis, we have configured the system so that the aggregation is done SQL-like. The execution, however, takes a few minutes at least. But we need to optimize the use of computer resources because there is always a limit of resources that are available. The flexible analysis is, however, realizable, but there is the need of limiting aggregation period. So let me summarize what I have discussed in the DS business. To achieve both general purpose analytics and flexible dedicated analytics, to meet both of these needs, we have employed this configuration analysis. Data mart have the master and the copy to ensure data consistency as a whole. And in terms of computing cost and storage cost, there are challenges, but they are mutually compensating each other as well. So this is also the summary for general analysis. The frequency of use is important. It could be a long time. Make sure that this is available to many. On the other hand, for flexible analysis, in-depth analysis is required, but it takes a lot of computing resources, so it will be available only for a short time. But having both types of analysis, we can meet a wide range of needs. And there are different needs for scaling. By having optimum scaling, it is possible to eventually optimize the total analysis. So let's move on to the last topic for today's presentation, that is rationalizing the pre-processing. I've talked about the overall system, but this topic is on a part of DS business functions. So pre-processing. It said about that 80% of the time required for data analysis is spent on pre-processing, so it is important to solve this issue. Standardizing your date format or labels. This will be an important point for us to be able to handle data going forward. So what I'd like to introduce today is the bottom part of this diagram. This is DS dataset handling part. So I'd like to introduce what this is processing. So what pre-processing is necessary for search query? So I'd like to introduce. The query is something that you user input. For example, what order may be different. It could be a difference between English and Japanese, although they do mean the same thing. So eventually, data solution Yahoo, Yahoo data solution, these are different in terms of word order. The purpose of analysis is to understand the recognition of user. They don't have to be the same thing. They are the same thing. The intention is the same. So we want to bind them together. So this keyword diversity is one thing that we need to analyze.
So in order to do this pre-processing of the keywords, there are two challenges. One is the realization of the appropriate division of the keywords, such as technical terms. The second is realization of the summarization by context. So for example, in this example, here it says Yahoo data solution. Is it one word, or should we divide it into the different words? It's difficult to know, because the product name and the different proper nouns are difficult to recognize. So how do we do this? in order to solve the pre-processing of the keyword, we are defining 3 rules, and those are the steps that we created. One is to divide keywords appropriately, for example, spacing and extracting the appropriate words, and assign labels to the tokens. So what is the intent behind each token, and how is it analyzed? The label will express such context. The third is to group the labels to achieve the complex aggregation. So grouping is done. We need to output the data so that the analyst can see this. So those are the 3 steps that we have. Now, in order to realize the aggregation, we need to manage the 3 rules, and we have this dictionary system and aggregation system here. So dividing the words and tokenize them cannot be achieved easily with the simple SQL. So we extract the data from Trino and summarize them in the aggregation system. The dictionary system, it's possible to register the earlier mentioned rules required for aggregation. Once registered, you can reuse it. Also, for example, what we use is, for example, creating the dictionary for home appliance industry. So depending on the client needs, we can make some adjustments. So we are starting to see this being utilized. So what kind of processes do we do? Let's look at each step. So here, what I'd like to introduce is about the trend analysis of the users. And this is an example of the pre-processing. So actual utilization, for example, the air conditioner, for each product, what users are interested in, the price or word of mouth, what are the areas that the users are interested in. So we are creating data to understand that. So the original statistical data are aggregated for each keyword. So there is a search query that is input by the user. So for example, the 商品激安 is one of the keywords, and the order of those words could be different. And there's a mixture of hiragana and kanji, and the orders of the words are different. So first of all, we want to divide them and make them into tokens. And the product name, for example, will be included. So in order to improve the efficiency, from the dictionary system, we create its own system to accommodate such product names and so forth. So next is labeling. So this is to summarize the intent of the analysis. So for example, gekiyasu or price means that the users are interested in the price, and the word of mouth and so forth, the users are interested in the evaluation of the product. So when you do the analysis, you will be able to choose some of the areas of the interest of the users. Lastly is to group the labels. So why do we group them? Only with the labels. This is for each product, so it's difficult to analyze. So what would be the unit of the summarization or grouping? So in this case, the product group has product A, B, and C. The price has only price. So if you want to aggregate those, and you can define that. So the final output is label and a group. And those are virtual. It's in one file. So label 1 is the price and the word of mouth and the product evaluation. And there are several things held in this virtual table. So ultimately, output needs to be read with the BI tool, and that is the key. So we want to make it easy to understand, use. So this is handled as one data. So in analyzing the search, we have realized the pre-processing, and also we implement a virtual table that can be handled easily in the analysis, and this is output. It is necessary to register for the first time, but then this can be reutilized, so the cost would go down. As a summary, so we looked into the generic analysis and flexible analysis in order to enable both. As a configuration, we talked about the configuration that we use, and to make sure that there is a master data in one place. And as for the pre-processing, we talked about the keyword, but how to create the necessary rules would be the important factor. In addition, we need users to use this, so output this based on the table structure is important as well. So for the future, it's still difficult to analyze for the long term. So how to optimize is one of the challenges, and also we need to strengthen the rule base and introduction of the AI. The other day, autofill was announced, auto FM was introduced, so that is something that we are considering. So with that, I'd like to end my presentation. Thank you for your attention.
Thank you, Mr. Yamaguchi. Now we will begin the Plus Talk. The interviewer will be asking in-depth questions on this session, and we will welcome questions from the viewers. If you have questions, please use the question mark button on the lower right-hand side of the screen. Please write down your questions. Interviewer is Mr. Tasuku Okuda from LINE. Would you like to introduce yourself? Hello. I am in the team of IU Data Connect data platform. In IU Data Connect data pipeline, that is to providing various services, external services, how we can send them to data platform. So it's ingestion pipeline development. Thank you for having me. Thank you. So I'd like to begin with my impression and also questions that I have. Throughout the presentation, not to have analysts wait, and whether you should use raw data or aggregation data, meaning depending on different dimensions, you are handling data depending on the needs. So it's a really proactive use of data. And there is also duplication. How can you manage your resources? So all of these different challenges you are dealing very well. As a matter of fact, in LINE we have common issues, like Trino. In order to show data as quickly as possible, we've introduced for service provision, and raw data and intermediate data, we have different uses. Some are used for in-house, some are for users, and depending on the users, what appropriate data should be utilized. So these are the questions that we have. So we have some commonalities between us. It's been very useful. So in order to use data for services, we have to have domain knowledge. Advertisement service or other API layer for a different service and so forth. So what goes inside data? You need to know about that, and you have to have the overall system and platform. There are different levels of knowledge. How can you learn that knowledge? Domain, system architecture. What are the difficulties between different levels of knowledge? It's a very difficult question. Internally, we have been utilizing data for a long time. For this service, we've already used that internally, and we have externalized that. So as we do use our data, general analytics has been the beginning. We have search queries, we can do this and we can do that. And we wanted to expose that for users because it's been quite convenient. So that's something that we've created. So in the beginning, we did not have Trino. But there are generally available data, and what's missing was really the user data. So we created that. And of course, we needed domain knowledge. We created data sets. Are they fitting for our users? And we actually explored different trials and errors. So trials and errors, we provided a platform. Services should be able to utilize data. So that's our new challenge. You go through trials and errors to find a solution. Yes. We have to have needs in the first place. Can we simply consolidate data? Is it good enough? No. How can we extract data? How we should view and analyze data? These are important questions. By the way, when there are needs, as you mentioned, needs come from somewhere. Utilizing data, services, people would think about in what way we can use data. And we have platform, API connections. We've developed systems, created architecture, and so forth. And I think that's done by your team. True? Externally, yes, we are working on that. As I mentioned earlier, we have analysts, and they carry out specific analysis on clients. And one of those results can be embedded in our system. Something that's effective, we would decide to externalize that. We have multiple flaws.
So at Line, if I may talk about Line, the service side, for example, can use it and they can do the batches and so forth, but not really the sophisticated system and others. It's difficult for them to try them. So something like that, the platform side, using the resources, API linkage and so forth, there's an organization like that. So data solution is exactly that. So accumulating data to some extent and use them, and those are the requirements that come out. So thank you very much. Also, you talked about Trino quite a bit. So system configuration slide was shown. If it's possible to show that once again. Page 15, I think it was in the middle. Page 15 or so. So I think we can wait as we talk. So linkage of the various services is possible. As for the concerning operation, so for example, you create system, operational problems happen all the time. So when you apply this to the service, this can be a major problem. So what is the structure that you have, or how do you prevent it? Any special operation that you have? Well, we don't really have any special operation. Maybe a little after this? Yes, this one. Thank you. Yes, no special operation. So the bottleneck, there are several areas that could become bottlenecks. The Trino, unless you reach the limit of the resources, you can handle this. So what is the excessive load? We need to know that. And how do you make it parallel so that your load will not increase the threshold? Total job server and maybe one service was possible, but we don't know how much is used. So we wanted to divide it. So platform is built by another team. So we were discussing with them, and say that there is a buffer of the CPU or memory. So we had such a discussion as we worked on this. So depending on the usage, and also it's not always at the peak. So during the night, sometimes it's a peak, and on the bad side, maybe the overnight, the nighttime is a peak. So you listen to the various requirements and set up the architecture accordingly. I see. Thank you. Also, toward the end, you don't have to show the slide, but you mentioned AI for the future. And AI, you're utilizing various data, and that I think you keep the high motivation, but it's difficult to actually utilize AI. So at Yahoo Japan, the data solution, in introducing AI, what are the difficulties, and in which phase are you? If you can share with us your thoughts. Well, it's a difficult question to answer because when we say AI, it covers a wide range. For the search query, to what extent do we use AI? So in understanding the intention, is it positive or negative? That kind of judgment, probably you need a separate AI. And this word, does this word represent the product correctly? So the categorization. So which part do you start is a major key challenge. So the word query and what is the category of the word? So categorization, I think, is one of the examples. And until now, partially we used it, and the category hit rate is what we have, and we want to improve the precision of that. So after that, using that, the data, for example, creating the dictionary is something we can do. So creating model and introducing it to the system algorithm, yes, we do that too at Line. But how do you do it with AI? There are different sessions in tech first, but it's still in process, and there are many challenges still. So as Line and Yahoo, I think that this is the area that we keep challenges, and there is a lot of room for further improvement, and maybe some areas that we can have a discussion together.
Also, well, service linkage, service connection. There are separate API layers for different services. According to this configuration diagram, we talked about how domain knowledge is necessary. Designing APIs, it is more than simple application development. It's beyond that. Data-related APIs development, is it more difficult? Data analysis must be understood first, how it's done and so forth. The time series data, the data that changes over time, unless you analyze that, you never know what is necessary. Search data, for example, we need to have the ranking information. Presenting ranking information is not analysis, but by comparing that, you can analyze, and you have to know that it is possible. So backend API, how it's possible to analyze. Of course, you have to be able to collect information. You have to have statistics information. We need all of that. In Line as well, we have multiple API layers, just like these. Say web application, developing stateless, it's very difficult to apply that in data area. How to deal with data, how to find data, appropriate data, how to make use of data that is available. ATL information, knowledge, data engineering knowledge also is needed. So hybrid knowledge is necessary. This is beyond the session you talked about. We talked about how it is important to find data. Think of catalog. We have a wide range of data. How can a data solution team or service team can find good data? I know it's a difficult question. Internally, we have data catalog, and the data will be available. our team, our department, has a team that creates location information and has dealt with search data for a long time. So we've known this area for a long time. So discovering data, the question is how to find new data. Analysts, for example, have taken this challenge, try to use different data sources, and we have a good cycle internally in our organization. So the contents of data are important, but the metadata on top of that is also very important. We have catalog tools in line. How can we communicate that to users, and how can we add data governance? How can we promote the utilization of that as well? These are all challenging topics. I think we have common problems. Yes.
I have some notes here. Going back to my impression of your presentation, so as a technical foundation and engineer, from the architecture level, it's very interesting. API design, web design, and data engineer, and so forth. And also to have a domain knowledge and how to develop the system, it's a kind of data management side. So it's a hybrid of both, and it's very interesting area. I'm talking about data solution. So this is, in other words, it's a difficult area because as technology, you have to differentiate from others and how to overcome the issues and challenges. It's a technical challenge and also the business-related challenge. So that is same for you at Yahoo Japan? Yes, technical challenge. Yes, the infrastructure is also related, and it's not just scale. So I think that might be reduced, but how can we provide data? So including line, we have to have data first, and that probably is one of the major point. I see. Thank you. I understand.